Hello viewers, welcome back. In this video lecture we are going to discuss some problems based on SN2 and SN1 reaction mechanisms. This practice session is very important. From my teaching experience, I observed that most of the time the students used to perform very well when the individual reaction topics are discussed. But when it comes as a problem based session or solving time, the students mostly get struggled because of lack of retention of the concepts. So in this regard, if you want to improve the understanding and the retention of the concept, so we need to do some good practice. So let us solve some problems here. Here the question is, here the predict the compound in each pair that will undergo the SN2 reactions faster. If you see this, the A, there are two pairs. Here there are two alkyl halides, and this is the one, this is the primary alkyl halide. So this is the primary alkyl halide and this is the secondary alkyl halide. As we know that in the SN2 reaction we discussed the factors affecting the rate of SN2 reaction. So the nucleophile always attack from the back side. So if the bulkiness is getting increased, the rate of reaction will get decreased. As we know that, so this is the order, the primary will go, before that the ethyl will go faster, then primary, then secondary, then tertiary. So that means the methyl will be faster and the least will be the tertiary. But if you see that here, this is the primary and this is the secondary, that means this A will go very faster. Okay. Now what about the B? Here both are the primary alkyl halides. Both are the primary alkyl halides. Now, but the leaving group is different. In the first case it is chlorine and the second case it is iodine. So as we know that which is the better leaving group? So this is the one we studied. So fluorine is the worst leaving group, and then chlorine followed by bromine and that's iodine. So iodine is the best and a good leaving group. So that means here that this iodine alkyl halide will go faster. What about the C? The same case, but you see here both are secondary alkyl halide. This is the both are secondary alkyl halide. Now how do we decide? See here, this is this alpha carbon and this is the beta carbon, and here there is more branching at the beta carbon. Here this is the beta carbon and this is the beta carbon, and there is a less steric hindrance in this case. That's why this will go faster. What about D? The same case. This also, this is the secondary alkyl halide and this could be the primary alkyl halide. So we know that, so the primary will be the least hindrance, so this will go faster. Here this is the primary and this is the secondary, so we know that this will go faster. So this is, both are primary but this is having the steric hindrance, that means this will go faster. So these are the answers for this, the first problem. Let us see that another problem for the SN1 reaction. Here this is the question, predict the compound in each pair that will undergo solvolysis. As we know that solvolysis means it is a SN1 reaction. They told that ethanol. That means here they are using the ethanol as a solvent that is going to act as a nucleophile, where the leaving group that will be substituted by the ethanol, that is ethoxy group, that is OET. Okay, I write it here simply, that is ethanol by SN1 mechanism or OET plus this leaving group. So now let's go into the problem. So before that, we just remember or recollect the information whatever we learned from the SN1 reaction mechanism. It undergo by the carbocation. So first step is the carbocation formation. The carbocation stability is most important. So that is a very important key step that we should remember for SN1 reaction. So in that case, which one will go form very easily? So this is the one. The tertiary will go faster than secondary, then primary, then methyl, because of the stability of carbocation. Okay, so that is the key step. So that we should remember. Now let's see here. In this case, this is the secondary alkyl halide. This is the secondary alkyl halide and this is a tertiary alkyl halide. Then definitely this will form a most stable carbocation. So this will go a faster SN1 reaction. Here this is the primary and this is the secondary. We know that secondary will go faster. So in this case this will go faster. So this is secondary and this is a primary. Okay, so this will go faster. Here both are secondary, but the iodine is a good leaving group, so why this will go faster. So here you see both are secondary, both alkyl halides are secondary, but this is connect to the benzene. Here it will form a this is benzyl carbocation here. So this will be a most stable than this tertiary. That's why this will go faster, because this can easily stabilize by the resonance. Okay, so this one will go faster. What about the F? Both are the secondary alkyl halide, but in the the second one, this one is forming like this carbocation. This carbocation is a allyl carbocation, which is more stable than the tertiary. That's why, so this will go very faster. Okay, so this all about the answers for the second question. So we should remember this concepts. So we have to do more practice in the forthcoming sessions. So I hope you understand these concepts. Kindly subscribe and share it if this video lecture is useful for you. Thank you very much.